Hello. That song was just about the right length, so I figure I might as well jump in here when it's done. So, as you might have guessed by the stream title, I am prepared to try getting a fast Fourier transform to work. That I honestly I expect it to be a complete nightmare. I expect this stream to be nothing but suffering while I try desperately to get some random FFT library to work. But before we get there, I will stare at my code a little bit and do some cleaning up. Yeah. Why is this? Oh, that's right. Yeah, I fiddled a little bit between streams. Not a lot. Let's look at this. I don't want it in that window. Boop. Boop. Oh, cool. Yes. It's weird. Oh, this is a tiny detail. OBS uses some method of determining what window you want to show them, looking at the title or something. It always remembers this browser window without me having to like tell it, oh yeah, hey, by the way, there's a browser window. It always remembers this. It never remembers VS Code though. I'm not sure why. Okay. Unmute. View the console. I don't think I need the view the console. Some other random song that I've actually never done this one before, I don't think. It doesn't look great. There's a lot of blue going on. Am I crazy or is it not synced properly? It did. I swear it did it again. Hold on. It's like a beat off. I don't know what's going on. It's very frustrating. It's like pretty decent. Like I can kind of tell that there's a lot of low frequency stuff. Ooh, it's quite loud, isn't it? No, it's me that's loud. Good. Got confused looking at my OBS meter. I can kind of see the blue waveforms are pretty wide in the background, which is great. There are definitely a few blue waveforms that probably shouldn't be. And that's the main issue that I want to try to address with the fast Fourier transform, because fundamentally it is a fact of life that your waveform actually has multiple frequencies, possibly infinitely many, but more than likely. I don't know. I mean, presumably it's as many waveforms or as many frequencies as there are instruments going on at the time. Something like that. Yeah, it's pretty good, honestly. It's like hurting my eyes a little bit because it's a bit much. It's a bit much going on. Oh yeah, okay, so this is one thing that I fiddled with is the fact that this is now at 100 FPS. All I did was I reduced the the number of frequencies we're trying to find. And I think I reduced... No, I've just... Like, you can tell. Yeah, I have the number of frequencies we're trying to find, and then it worked pretty well. So, yeah, another thing that I was thinking about last night, because, you know, this project haunts my dreams, is... I know that the fast Fourier transform probably can't tell me the frequency with like pinpoint accuracy, and that's fine. I think it will probably do way better than even this, which is already amazing. But I was thinking to myself, you know, it doesn't have to be perfect because there's not even that many colors that I can like I can really distinguish, that humans can distinguish, I guess. Like I mean realistically there are, but the in this context where we have a very chaotic waveform bouncing up and down, what happens is like between frames you like see an after image of the last frame, but at like half opacity. That's the best way I can describe what I'm seeing, at least. That's not a part of the program. That is just like what happens. I could have something to do with the gray background as well. So yeah, because of that fact, I'm like, you know, I could probably deal with like 5. Like if we could classify that, because kind of what would be interesting is if each different like instrument in the song got a different color, something like that. And there's never that many instruments going on in a song anyways, even though they are changing tones. I don't know, it's like we don't need to be able to classify that many frequencies. So if this fast Fourier transform thing doesn't work and we are trapped, we are stuck with our sine curve fitting procedure, I could probably live with that. Like even though it's like pretty computationally intensive, I could probably live with it. And another thing is this whole brute force method of searching isn't great either. We just try 60 times 25 different things, and I'm almost certain that you could like use this same number of attempts and sort of like use gradient descent or something to more intelligently narrow in on the correct answer. I'm really hesitant to do that though, because like we could try using like literal gradient descent, and that would be tricky to implement. And I'm like scared to do that because I already know that the terrain of solutions and the terrain of correctness is very bumpy. It's very easy to get trapped into what do you call it, like a local minima, something that's like optimal nearby, but it's actually not the optimal choice overall, with something like fitting a sine wave to something that is very much not like a sine wave. I mean, it's only vaguely like a sine wave, I guess. So I am concerned about things like that. Wasn't I gonna clean up this code? I think I was. Okay. Oh, I actually might want to keep some of these. Hold on. I want to keep that. I'll keep all this, actually. I'll keep all of this. I'm not using this at all. Frequency color stops is declared up here. Log counter is a log counter. Probably won't ever use interpolate colors again. Just gonna kind of like look through this, make sure it makes some sense. What is this? This draws the background. That's right. I don't really... Oh, I use this for the FPS counter. That's right. Yep, that looks good. One of these days I'm going to have to solve the synchronization issue. That is for sure. I've done it before, but it is tragically prevalent. It's like unavoidable. Audio time string. Audio time string. Oh, that's the how many samples into the song we are. We draw that at the bottom. That's right. Yeah. And this, I think all this does is determine the max amplitude. Can I make this a function just to make me feel better? So I don't have to keep looking at it. Because I can literally just copy paste this. Love it. Great. I'm looking at this now. I remember I fiddled with this a bit, and it might have been ill-advised, the fiddling that I did. I don't know. Like, this could be why there was that, like, solid blue background in that example we just saw. This seems weird, right? This seems weird. Couldn't I just say, like, if I equals 0? Because we really don't need the previous x and y. Do I break this out into a function? I think I may. I think I may do that. Basically put it at the bottom. Is this it? I think this is it. It's basically this. It's even... Well, it's like kind of both of these things. Yeah, let me see. Yeah, this is great. Perfect. Okay. Awesome. I love it. Much simpler looking. Okay. I guess I'm I'm procrastinating. I really don't want to mess with the fast Fourier transform. It's not really that. That's just a really important and useful thing to be doing, is refactoring stuff. Okay, I'm gonna go on an adventure now. Okay, I bookmarked a particular fast Fourier transform library. It claims to be the fastest. So we're going to go to NPM, see if we can find it on there. That seems reasonable. Okay. Mm-hmm. Wait, why is it down here? But it's a little bit strange, not gonna lie. A little bit strange. But that's fine. Okay. And then I need to be able to use it somehow. It's not obvious that I will be able to use it how I want to use it. Okay, how am I gonna stick this thing in here? I definitely want to be generating a fake sample. So that goes away. You know, I probably don't need V2 anymore now that I'm outputting this. Okay, and this is now going to say just that. Oh yeah, and I remember, okay, let me look at the documentation real quick, or the, I guess just the README. Yeah, there's a constructor, and the number of samples you give it needs to be a power of 2. Let's see if I can even import the thing, though. It's like... It wants to be like this, but does that just work? Right, it wants to be like this. That's not how you spell that. Const. Right, okay. Okay. Yeah, I'm relying on the IDE to help me out here. Import star as blank from blank. Is that how you do it? Probably not. Do I mean to set the module resolution option to node? Maybe. Maybe I mean to do that. Or maybe I'm just writing this wrong. Import star as FFT from this. Right? Not, no. My muscle memory. Yeah, let me try setting module resolution option to node. Which I don't think happens here. I think it happens here. Yeah? Are you happy now? It's not happy. This module can only be referenced with ECMA script imports exports by turning on the allow synthetic default imports flag. Okay, that's probably fine too. I'm approximately familiar with this. I've at least seen these before. Okay, it's still mad. It's still mad. Do I do this? Is that... Oh... What is its default export? Oh, hey, we got there. Yeah. Woo! TypeScript, everybody. TypeScript. All right. Okay. We've done it. Okay, how do I use you? I do like new FFT, I think, right? Okay, it needs a size. Okay. So what I want to do... You know what I'd like to know? Is if this sample neighborhood, how this relates to the size of the sample that we get. So before I even try this, I'm gonna, and before I mess with this again, and I'm gonna delete this. Also, Webpack might explode now that I have a new... Okay, no, it's happy enough. It's happy enough. .401, yes, I actually suspected there would be an off by one error. How do I deal with that? I guess I have to arbitrarily choose. Okay, so low is 0 or... Oh, and right, there's also that problem. I could fix that with an if statement, right? Oh dear. Right, just like the first I mean, it would literally be a frame or two. It would literally be a frame or two. Um, the first frame or two won't have enough samples or the expected number of samples, and that would be a problem. So we would just have to throw those frames out, which is not. That's actually fine. That's a power of 2. This times 2, basically. Okay, so now I expect to see 512. And I do see 512, and I'm happy about that. Does this have a type? What is this thing? It is of type FFT. Of course it is. Of course it is. Why? What more do you need to know? What more do you need to know? Oh dear. Question. Is doing this every frame a bad idea? I bet it is. I bet it is. Does the documentation tell me something about that? I'm just gonna assume that it would be a bad idea. So you're not happening in the draw frame. You're happening up here. And sample neighborhood is also coming out. That's fine. That's good. Okay. Now I do something like real transform is what it's called. Take an array of real numbers, input, and perform FFT transformation on it, filling the left half of the output with the real part of the Fourier transform's complex output. Okay. Too many dots. Yeah? No documentation. It expects an array. Well, I know the input is just going to be sample window. I hope it's happy with that. it expects an array of real numbers. I think that it'll be happy with that. I need to fill an array. I need to get an array. You know, I'm pretty sure the way JavaScript arrays work, this should be totally fine. I don't actually have to, like, do allocation and stuff. Like, you can have jagged arrays in JavaScript. Or is that what I'm thinking of? Jagged arrays? That's not actually the right term. Arrays with like an incomplete list of indices, I'm pretty sure. At least as long as you're like assigning to it, I think. Okay, so we're gonna stick this here. Hello? Did my keyboard lose focus there or something? That was odd. Just out of curiosity, I want to see if my suspicion is correct. Ta-da! I think. Wait, hold on. Concern? Concern? Why no draw? Why no draw? It no draw. Why it no draw? It's not drawing anything. I'm concerned. Okay, we have a new puzzle. We have a new puzzle. And I'm pretty sure the puzzle is not related to this. Yeah, no, it's not. The puzzle is... why did it stop drawing? What have I done? I surely call draw waveform. Okay, what's the problem? Samples. Samples.slice. Actually, I wanted to be using this. If I'm honest. That doesn't really matter. Is this because I changed to the sample neighborhood? Oh, no. No, that actually shouldn't matter because this references audio samples.length. Huh? is my line color on the fritz, right? If I do this, could also be max amplitude that's broken, right? Okay, let me eliminate that possibility as well. This is what I do whenever I touch code. It just breaks. I don't understand. Okay, so we should expect to see a 1000 frequency waveform. We literally don't. We don't see any of that. Okay. Hello? I'm so confused. Oh boy. I think that's what I needed to do. I think that's actually the answer. This used to be like a negation of the logic that I thought it was. I misread it when I was refactoring it. I'm pretty sure. I'm pretty sure that's what happened. Yes, okay. We go back. We turn back on everything that was turned off. Line width fanciness. Line color fanciness. And let's turn off the sample, the fake sample, and try using the actual sample real quick. Just to make sure. Is it quiet? Oh. It is. It's out of sync again, but that's fine. It's expected. Yeah. It's working again. Great. Okay. And now we bring back the fake sample. We take you. We're going to plug you into the FFT and we're going to console.log the output. Yes. Yes. Okay. Yes. So this is it. This is our... How trippy is that? That's cool. And we get to do something with this. Yeah, honestly, not sure what to make of this at all. Oh, it shoots up someplace over here for some reason. So the largest values are over here. There's some negative values too, which is really odd to me. Kind of not expecting that. Okay. Now I get to do some research. Sample rate and n is the size of the FFT. Okay, this Stack Overflow article is pretty cool. So each of these is a bin. This one corresponds to frequency 0. And each one after that increments the frequency that it's looking at by sample rate divided by n, where n is the size of the fast Fourier transform. So I think in our case, n is 512. N is 512. Oh, hold on. In their example, they're saying it actually might be 1024. Ours might actually be 1024. Okay. So sample rate, our sample rate I think is 44,100. Might be useful to print that out. Let me print that out real quick. Okay, it's 48,000, not 44,100. Okay. So if we did 48,000 divided by 1024, that is the frequency of the second bin, the bin with index 1. So if we take, I don't know, what's the highest one here? Jeez. This one is kind of the largest amplitude. It's like the largest absolute value, even though it's negative. This is 22. So if we do 22 times 48,000 divided by 1024, so if that spike, oh god, this is so bizarre. If that spike is meant to indicate what our frequency is, then it's basically correct, I think. So to be clear, I claim to understand the theory of this roughly. Where, well, do I claim to understand that? So from what I've read, this gives you the coefficients of a series of sinusoids that you sum up to get exactly this signal. Or like approximately. Well, I mean, for this particular waveform, I imagine you could get it like exactly. But so like, if we don't have a bin that exactly aligns with this frequency, then it's gonna like sort of spill over into the other bins a little bit. Which I guess is okay. I can live with that. Huh. One of the so this is kind of okay. It's yeah, this is kind of okay. One of the things that I saw suggested online was you could take your samples, and when you put it in an array, put it in a double-sized array and leave the latter half of the array as a bunch of zeros, and that's supposed to do something for you. What, I don't know exactly, but it might do something. Cool. So let me, while I understand this, let me try programming the frequency in it. Okay. Or like, as I'll put it in as a comment, right? Okay, that seems correct. Okay, then ta-da, ta-da, ta-da. Okay. We feed it the input now. So let's see what that does. Let's see what that does. I'm gonna grab like a screenshot of the previous bins we were looking at and see if we see a difference. Yeah, okay. Okay. Ooh, still 1024? Oh, hold on. I declared FFT with the wrong size for this. I actually need to do 4x. What did it output? Did it just ignore the, Okay, it seems like it ignored the latter half if the size is wrong. Okay, but I fixed that. Okay. Now where do we expect to see it? We would expect to see it at 44? Yeah, approximately there is like the spike again. Okay, 43 in fact. Okay. It honestly does not seem fundamentally different than what we did before, which is fine because it seems pretty good as it is. So if I apply the formula from before, this has been number 43. The sample rate again is 48,000. Divided by 2048. Hey, look at that. That's really good. That's really, really good, actually. So this might be saying to me that the you can cheaply get 2x accuracy out of your fast Fourier transform if you just fill up the latter half of an array with zeros. I guess that's what that's saying. Cool. So now I wonder what happens if I plug this fast Fourier transform into a frequency finding algorithm, right? I don't hate this. I definitely don't hate this. Yeah. Converting it to a color is going to be interesting, but it seems pretty cool. My throat is killing me right now. Sorry to blow my nose. Did I keep around this the method I could use to transform this into a frequency? I don't think I did. No, that is lost to time. Oh well. For the sake of ensuring the efficiency of this, I'm not going to do this doubling trick, because I don't think I don't think it'll really matter. Or like I want to, like, I don't think having double the frequency accuracy matters, because even as this is right now, it's way better at frequency accuracy. What's a little bit odd is that the is that the frequency bins are spaced out linearly. That could kind of suck a little bit. Whereas with my frequency algorithm, I can space out the frequencies that I test exponentially. So it's possible that I will be like, you know what, I need the double the accuracy, or like X times the accuracy. I want it. Maybe. We'll see. But for now, we'll leave it like this and see what happens. Okay, so this does that. It puts it in the output, and then we iterate over the output. Is there a max function? No, you could do like a... What could you do? You could do like a reduce to get the max, but I'm not going to do that. Hold on. I actually want to make a variable for this. Oh, it's the output. It's the output. Yeah. I hope this is going to be run really fast. I hope it runs really flippin' fast. Okay. So we don't need this. Do not call that ooh. I'm not dealing with decimals today. No. No decimals. Do not want decimals. Okay. I will likely forget the order of these three things that I've just listed here. Okay. And then we're going to get back to making it a difficult thing. Okay. Now, hold on. Let's try it one at a time. So I'm going to leave the frequency constant, but I'm going to alter the phase. If FFT doesn't suck, it should be able to handle me changing the phase. Okay. That's interesting. It produces slightly different things that are all pretty close regardless. Huh. I guess I'm happy enough with that. Okay. And then let's put it to the true test, I guess. It is extremely good. FFT is extremely good right now. Oh my god. Judging by looking at these differences, they're all less than 100. Oh my god, FFT is so good. Oh, hold on. I think I saw greater than 100 for a split second. No, I don't think I did. I mean, I like saw 90 something, so. Wow, dude. That's pretty cool. Okay. So, what have we learned? We kind of like FFTs. I'm pleasantly surprised. I'm pleasantly surprised so far. So the only thing left to do is to run it on an actual song and see what it gets up to. Yeah. Yeah, that seems reasonable. It could output 0, it occurs to me. It could output 0. Been writing too much Python. Okay. If the frequency is equal to 0, then let's choose that octave as 0. Otherwise, you take the log of it. That should be fine. Yeah, like it did pretty well with perfect waveforms, perfect sines, right? Let's see if it's really terrible with... I mean, it's honestly gonna probably be impossible to tell for sure, but let's see. It'll certainly run at a higher frame rate. That will be at least a significant improvement. Oh, I wish I didn't have this weird synchronization issue right now. Dude. You're killing me. I'm dying because of lack of synchronization. Please. Is it... Hold on. I'm trying to wonder if something I did messed with the synchronization. Oh, dude. Oh, the synchronization. It makes me so sad. I'm so confused. Okay. I think the fast Fourier transform is actually fine, but the fact that it's not synchronizing properly is making me very sad. How can I measure this problem? Well, wait, don't I draw directly from the audio context time? Okay, hold on. 512 samples, which is the window. 48,000 divided by 512 is 1/100th of a second. That's way more than the desync we're seeing here. So that can't possibly be related at all. Why... I need like a slider to configure the like some amount of desync, because this is killing me. It was working before, which is the obnoxious part. Like, it seemed to be perfectly synchronized. I'm very paranoid. Right? I literally say, hey, what's the current time? Audio context. Tell me the current time, please. Am I using this wrong? Right? Maybe I'm using this wrong and this is not the elapsed time. Let me... Okay. Let me do a quick Google search about that. it starts at 0. But it's not saying that it starts at 0 when you hit play. It seems like it starts at 0 when you create the audio context, which we do like right at the beginning, and we keep it around forever. Okay. Why do I do it that way? Wait, okay. Huh? Surely this is like doing the exact same thing. I must have misunderstood exactly what I was doing before. Anyways, play start time. That should work better. This... Oh, hold on. This is reversed. Okay. What was I doing before that made it not appear like there was a delay? What? Huh? How was that ever working? Yeah, this clearly seems to be synchronized now. Ta-da! I fixed it. Okay, it's very strange. I think it's working great. I think it's fantastic. I couldn't be happier with that. Well, okay, I could be a little bit happier, but no, I think it's really great. I think it's really great. It runs at full frame rate, which means it's way more efficient than the method I was using. Well, I actually don't know for sure how much more efficient, right? Because it could be like right on the cusp of lowering the frame rate, but I'm pretty sure that it's actually like way faster, like way faster. Oh, paranoia check. Is desktop audio working? Yeah. Okay. I just love the low frequency stuff at the beginning of the song. It just looks so cool as a waveform. I love it. It looks so cool. It looks so cool. Um, cool. Wow. Wow. Did not expect that to go so well. Well, now what? Now what is the question? This is out of date. Uh, is the T in transform capitalized as well? Probably. What I would like to do, okay, the frequency to color gradient map could obviously be better, I think. Uh, I would like to be able to use hue values rather than RGB. Yeah, I mean, like, I could fiddle with these color stops if I really wanted to. I could fiddle with these color stops for like a long time, and maybe eventually get something that works. But being able to convert, uh, what is it? HSL, HSV? I thought it was HSV. Yeah, HS. It's hue, saturation, volume, right? To RGB. I'm Googling around to see if I can find something that lets me do that. Oh, geez, there's just like a chain of people copying it over and over again. Good lord. And the original person copied it from Wikipedia. Oh, weird. There's HSL and HSV. Hue saturation lightness and hue saturation value. I think I want hue saturation lightness. The HSL representation models the way different paints mix together to create color in the real world, with the lightness dimension resembling the varying amounts of black or white paint in the mixture. E.g., to create light red, a red pigment can be mixed with white paint. This white paint corresponds to a high lightness value in the HSL representation. Fully saturated colors are placed around a circle at a lightness value of 1/2, with a lightness value of 0 or 1 corresponding to fully black or white respectively. Meanwhile, the HSV representation models how colors appear under light. The difference between HSL and HSV is that a color with maximum lightness in HSL is pure white, but a color with maximum value/brightness in HSV is analogous to shining a white light on a colored object. The issue with both HSV and HSL is that these approaches do not effectively separate color into their three value components according to human perception of color. This can be seen when the saturation settings are altered. It is quite easy to notice the difference in perceptual lightness, despite the V or L settings being fixed. Oh, interesting. I would kind of like the perceptual lightness to be constant, and I just want to vary the hue. But if I were in this domain, I could just vary the what is it? Vary the lightness up and down until I get an RGB value that is the same as all the others, I guess. Formal derivation. Oh geez. Oh geez. Lightness. The original purpose of HSL and HSV is color selection tools. Mm-hmm. Color conversion formulas. Aha! To convert from HSL or HSV to RGB, we essentially invert the steps listed above. You don't say. Okay, HSL to RGB. Given a color with hue 0 degrees to 360 degrees, saturation 0 to 1, and lightness 0 to 1, we first find chroma. Okay. Okay, I can do this. I can code this. Mm-hmm. Then we can find a point R1, G1, B1 along the bottom three faces of the RGB cube with the same hue and chroma as our color, using the intermediate value X for the second largest component of this color. Oh god. The remainder from Euclidean Division? What? Okay. What do we call this thing? It's capital H tick. Or a capital H prime, I guess. Is equal to H over 60 degrees. Q over 60. Yeah? And then let X... I should copy and paste this. X is equal to chroma times something. 1 minus the absolute value of H prime mod 2 minus 1. In the above equation, the notation H prime mod 2 refers to the remainder of Euclidean division of H prime by 2. H prime is not necessarily an integer. That is true. That is true. I don't... What would it do? Like, if I come over here... And I'm like, 12.5 mod 2. Okay, JavaScript is pretty nice about this kind of thing, fortunately. I think we're gonna be fine. Yeah, we're gonna be okay. Okay. And then, so that disclaimer is fine so far. In the above equation, no, okay, and then it just says R1 G1 B1 is equal to this. And it's a sequence of if statements depending on the value of H prime. Okay. Yeah, I can do that, I think. OBS disconnected. And then reconnected. I love it. We love it when that happens. Stream still says I'm streaming, so I guess we're good. Let's see, 3, 4, 5, 6. Okay, that's good. This should just be an else statement, honestly. If it's 360, so it gets really mad if you enter 360? That's strange. Huh, interesting. So, CX0, various combinations of that. Okay, so the first one is CX0. I'm basically just copying from Wikipedia. CX0, XC0, 0CX, 0XC, X0C, C0X. Every possible combination there. Where h prime is an integer, when h prime is an integer, the neighboring formula would yield the same result as x equals 0 or x equals c as appropriate. Okay, thank you for that extra detail. Finally, we can find RGB, the true RGB, I guess, by adding the same amount to each component to match lightness. Okay, so M is some amount that we add to each component. Okay. L, which is our lightness, minus chroma, which is C, over 2. And then we return temp color R, red, plus M, temp color green, plus M, temp color blue, plus M. Ta-da? I think. Ta-da. I think the answer is ta-da. Okay. How do I test this, though? That is my question. How am I going to test this? So for starters, I could be like, and then map it to a number from 0 to 360, and then I think that's approximately what we would want to do. Is this mad at me? Oh, and then we do get style. Yeah, and then I think we run that on the fake sample, and we don't care about phase exactly. Well, and we give the frequency we just use the exact frequency. No idea if this will work. Shockingly, we just get a black line. Okay, why? Why? Okay. Let me make sure that hue is outputting something sensible. Yeah, very good. Very, very good. I love that. I love that a lot. Okay, so hue being from 0 to 360 is perfectly sensible. Double check. If I have a lightness and saturation of 0.5, would I actually expect that to give me a reasonable color? Saturation. I actually would want saturation to be 1. But realistically, a saturation of 0.5 should still be fine. Yeah, I'll change. Let's see. S is the second one. Change that to a 1. Not like that. I expect that to give me something that is not solid black. We can stop console.logging that, I think. Yeah, so it is well and truly broken currently. Let me grab the line color and output the RGBs. Weird. Oh, you know, it might be on its way to being correct. It's just mapping to numbers 0 to 1, which is not what it's supposed to be. What? Come on, Wikipedia. You know that RGB is numbers 0 to 256. Does it say at the outset? Yes, it does say at the outset. RGB is number 0 to 1. Aha! Okay, I can fix this. Okay, I can fix this. Okay, I can fix this. Oh, I should have just done that the cool way. That might literally just be all I needed to do. It is red. Oh. Very nice. Kind of. One thing I do like about this is it all the colors are pretty bright. Well, I mean, except that blue purpley one. Okay. So I think the HSL to RGB conversion is working. If I remove if I like turn off the auto, the fake generator thing. I think that will work. Oh dear. Cannot read properties of undefined, reading red. Line 79. What? So temp color is undefined. Oh, okay. I kinda could see how that could happen. Kind of. Honestly, this should do some clamping. Oh, but the clamping is like has those built-in assumptions. Uh Okay, what if I come back up here? I can know here. I don't hate it. I like it a whole lot, actually. Oh, it broke again. Oh, why you break? Of course it's gonna break at the same point. Why wouldn't it? Okay, I'm 95% sure that is happening. That is happening in this little edge case right here, where hue is exactly equal to 360. So h prime is going to be equal to 6. So if I put this here, magically, it'll fix the issue. Just watch. Don't believe me, just watch. Called it. I love this. I love this so much. Oh, that's so cool. Oh, that was really cool. This song is a really good showcase. This song is a really good showcase for the visualization, because right there, it moved up through so many of the frequencies. Oh, that was awesome. Oh, that was awesome. One thing, I think I'm about to call it quits for today, but one thing I was thinking of that would be pretty easy to implement now that we have this hue thing. I really like this hue thing, not because the color wheel that I just generated is that amazing, but because it makes the problem of changing colors into a one-dimensional problem. And that's fantastic. Because if what I could do is I could come over here in our new fancy get frequency v2. Do I need this comment here? I don't need this, certainly. Our new fancy get frequency v2. And it's pretty clear that you know what occurs to me. All these get frequency functions. They really should have been get color functions, because that's literally all I use them for. But that's like a programming architecture consideration. Anyways, so we get all these bins, right? What if we took all the range of bins? Okay, we do absolute value on all of them, and I guess we would have to take the log of their frequencies, like we're doing up later in the program, or maybe we don't do that. I don't know. Because I think this is like symmetrical. Yeah. But what I was thinking is we convert for each frequency we map it to a hue, and then we do a weighted average of all those hues based on their magnitude, their absolute value that we get from the FFT. I think that's worth trying. The reason why I think that that's an interesting thing to do is, like I said before, any particular signal, any particular sample that we're looking at, okay, not sample, sample window that we're looking at, we could have the case where there's like two very different frequencies going on, and we just have to pick one at the end of the day. So like we could have the like a big fat wave going on, and at the same time it's like all bouncy in that big wave at the same time, and that is a combination of two frequencies. And if we could communicate that as a combination of two hues, that would be pretty cool, I think. But I would really like it if that mapping that we do will give you like precisely one hue for like the base case of there's just one frequency, like when we were testing it. Like I would like it if that maps very simply from our 0 to 3 from frequency to the 0360 hue. but I worry that when you add in the that weighted average, you're doing that on like you're having to convert, you're having to do like the log of the frequency to get to the hue first, and then you do a weighted average of that, and I'm like, mathematically that doesn't feel very good. But it's very possible that at the end of the day that doesn't matter. Let's see, the weight would be you take the absolute value of the amplitude, and then you divide it by the max absolute value amplitude that you see over all the bins. Or do you divide it by the sum? Should you actually divide it by the sum? The sum of the absolute values. You probably should actually divide it by the sum. Is it true that the because that's the thing, right? It depends on what the FFT actually is. Crap, dude. Probably for starters, I would divide, just because I'm worried about the using the sum. But it needs to sum to 0 when you do the weighted average. Yeah, the whole point of the weighted average is that it sums to 1. It should sum to 1. Yeah, so would doing that would it be biased by the noise? Because I remember looking at the FFT, we saw there was that big spike, but then over towards the edges there were like ripples up and down. So it seems very probable to me that if you do a weighted average of that, huh? HSV is supposed to be all about mixing colors, but our color mapping is logarithmic. Oh boy, our color mapping is logarithmic. But it should be. Like it clear I think it's really good that it's logarithmic. Like it works. It really works. So like color mixing of log colors it could be really shit is what I worry about. Okay. So this is all done basically, and I'm going to write some more specific notes. Can I try using the FFT, using all the FFT bins to generate a weighted average hue? That is something I really want to try. Because that, I claim that doing that will help us out in those edge cases of the song that I saw before, where clearly musically there's a lot going on, but we're just stuck with like the same color, which happened to be red, I think. Yeah. I'm also I'm assuming that issue with it being stuck on red was that this will help that issue, and that's not like a problem in my code, but I'm pretty sure that is what is causing it, where it like gets confused and it can only pick one frequency. Yeah, I think that's right. Really happy with the FFT today, though. Pleasantly surprised. Expected it to make me miserable. It truly did not. Truly did not make me that miserable. Alright, I'm going to call it a day, though. Thanks for stopping by. Hopefully I'll see you tomorrow. Farewell.